Hi and welcome to a video tutorial on how to do trigonometric integrals. Today we'll be looking at the specific case where sine is raised to an odd power and cosine is raised to an even power. Now the first step is save one sine. The second step is to convert the rest to 1 minus cosine squared x, and this comes from the identity sine squared x plus cosine squared x equals 1. So this is a very important identity, and we can get 1 minus cosine squared x from this identity by just subtracting the cosine squared x. So sine squared x equals 1 minus cosine squared x. So sine squared x is the same thing as saying 1 minus cosine squared x. Then, step 3, we're going to set u to be cosine x and du to be negative sine x dx. And then we'll just integrate it. So let's look at this example right here. Sine is raised to 3, which is an odd number, and cosine is raised to 2, which is even. So let's go through these steps. So first, we're going to save one sine, and then all we'll have left is sine squared. Okay, so we saved one sine, and then we'll have left is sine squared x. This comes from, so sine to the third x is the same thing as saying sine to the first x times sine squared x. The whole idea here, it's like if I had x to the third, that's the same thing as saying x to the x squared times x to the first, because x squared times x to the first is the same thing as saying x to the 2 plus 1, which is just x to the third. Okay, so that's where x to the first, sine to the first x times sine squared x is the same thing as saying sine to the 1 plus 2x, which is just sine to the third x. So I'm basically rewriting the sine to the third x into this form. So that's what I mean by save one sine. Okay, so we save one sine. Step 2, we're going to convert the rest to 1 minus cosine squared x. So we're going to convert this to 1 minus cosine squared x times cosine squared x dx. Okay, now step 3, set u to be cosine x and du to be negative sine x dx. And let's rewrite this and make the negative go on the other side. So basically we're going to multiply this by negative 1, and we're going to multiply this by negative 1 to get negative du. Well, negative times a negative is just a positive, equals sine x dx. So I just rewrote this just to make the negative on the other side rather than on the side with the sine x. Okay, so now we're going to substitute in. So sine x dx just becomes negative du, so I'm going to put the negative outside of the integral and put the du here, and then 1 minus u squared times u squared. Okay, so now I'm going to distribute this u squared in to get u squared minus u to the fourth du. And now I'm just going to integrate this, so this is going to be negative u to the third over 3 minus u to the fifth over 5 plus c. Now, we have u's, but we started off with x's, so we need to go back to x's. So we have to substitute back. So u is the same thing as saying cosine x, so we're going to put in, so wherever we see a u, we're going to put in a cosine x. So cosine, well, to the third x over 3, and then this is going to be cosine to the fifth x over 5 plus c. And we could distribute in the negative, so it would be negative cosine to the third x over 3 plus cosine to the fifth x over 5 plus c. And this is our answer. Okay, so that's one example. Let's do one more example. Okay, so let's do one more example where sine is raised to an odd degree and cosine is raised to an even degree. Okay, so we're going to save one sine. So we saved one sine, and we're going to convert the rest to 1 minus cosine squared x. But in this case, we have to watch out because this is sine to the fourth x. So sine to the fourth x, I'm going to write it on the side. Sine to the fourth x is the same thing as saying sine squared x times sine squared x. All right, and sine squared x from our identity over here, sine squared x is the same thing as saying 1 minus cosine squared x. So this becomes 1 minus cosine squared x, and this becomes 1 minus cosine squared x. And 1 minus cosine squared x times 1 minus cosine squared x is the same thing as saying 1 minus cosine squared x squared. So we have to square this. Okay, so let me just erase this stuff. Okay, so step 3, we're going to set u to be cosine x and du to be negative sine x dx. Let's bring this negative to the other side. Okay, so we rewrote this. So now let's substitute. So wherever I see a cosine, I'm going to put a u. And where I see a sine x dx, I'm going to put a negative du. So I'm going to put the negative on the outside, put the du here. So I substitute that and that. Now I'm going to do 1 minus u squared. So u squared squared u to the fourth. Okay, so now I'm going to do 1 minus u squared times 1 minus u squared. So 1 minus u squared times 1 minus u squared, when I FOIL that out, I'll get u to the fourth minus 2u squared plus 1 times u to the fourth. Now I'm going to distribute in that u to the fourth to get u to the fourth times u to the fourth. So that's u to the fourth times u to the fourth is the same thing you have to do. It's just u to the 4 plus u to the 4. U to the 4 plus 4, which is u to the 8th. So this is u to the 8th minus 2u. Same idea here. So this will be u to the 6th plus u to the 4th. Okay, now we're going to integrate this. So we're going to get u to the 9th over 9 minus 2u to the 7th over 7 plus u to the 5th over 5 plus c. So now we have u's. We finish integrating, but we have u's. And we started with x's, so we need a back substitute. So this is going to be, well, u is cosine x. So this is going to be cosine to the 9x over 9 minus 2 cosine 7x over 7 plus cosine to the 5th x over 5 plus c. And lastly, we could distribute in that negative to get and that's our answer. So I hope this cleared up any confusion. I really hope this helped, and good luck.